melting at 700 years. Right in here is where I believe the woolly mammoth really bit it by the millions in there, because the permafrost increased and then reached a peak at the end of the Ice Age, and since has warmed up some, forming hollows and hills called edamas, permafrost features due to melting of the permafrost. And the woolly mammoths are mostly in those hills and in the lakes that form those hollows between the hills in the permafrost. Some of the evidence that there is no permafrost for quite a while is the distribution of the saga antelope. Now, the saga antelope has very small hooves and likes open country that is dry. Because there's permafrost in Siberia today, it's a swampland, and it's hard to get around. Saga antelope can't negotiate swamplands, but yet we find them as fossils in these areas that are dotted here. Even on the New Siberian Islands, northeast Siberia, the lowlands around Fairbanks, up there in northern Alaska and northern Yukon, Central Asia, indicating that it was an open plains. In fact, the evolutionists have come to the conclusion that it was a big, huge grassland, totally unlike the vegetation there today. The vegetation there today, they can't eat. It's swamp vegetation. It's very lush, but it's toxic to these mammals. Besides woolly mammoths, you had woolly rhinos, horses, bison. They're grass eaters, and that's what you had as a grassland. And to make a long story short, this is kind of the timeline for the woolly mammoths. Well, they started as two woolly mammoths coming out of the ark, or part of the elephant kind that split off into mammoths and mastodons and elephants. I don't know. I favor that there was two elephants of the elephant kind and that they split off. That's what I favor. And they start slowly based on their reproductive, they reproduce very slowly. But then, just like geometric progression, you get a calculator, hit 2 times 2 times 2, keep at it. It goes up slowly, right? 4, 8, then suddenly, it really mushrooms. And this is how it would be with the woolly mammoths. They reached populations of millions towards the end of the Ice Age, and suddenly, because of colder, drier, windy climate. They weren't used to a colder, drier, windy climate. Climate was a lot different up there. But then how did they die off? This is the major mystery. How did they die off? See, by the way, I am summarizing a whole hour talk to you just in about 5 minutes on the woolly mammoths. So if you want to know more, if you're confused, I got a lot more details on the woolly mammoths and the Ice Age down in a layman's book down there called Frozen in Time. A solution to their mysteries of extinction is found in the deposits surrounding the mammoths. Let's look at what they're buried in. Okay? Well, the experts say they're buried in windblown silt called Luss or Loose or whatever. The Germans, there's a really interesting pronunciation of this with an R sound in it. I'm not even going to attempt it. I am not an English major. I'm poor at it. Everyone has to edit my works, including my wife's the first one. So a particular interest for the paleozoologist is the Eudama. Those are those hills. This is actually a loess layer, as a rule containing the largest amounts of remains of late Pleistocene animals. So they died in dust storms, or they're buried. I think a lot of them died naturally and were covered up rapidly by mediocre dust storms. You know, just your average run-of-the-mill dust storms that maybe leave that much dust. But you get enough of them in the dry, windy climate at the end of the Ice Age, you'll bury them pretty fast. But some of the more exotic observations, which are rather rare, of the woolly mammoths, I think died in gigantic dust storms. So I went to the Dust Bowl era as an analog for a dust storm. And here's a picture from the Dust Bowl era. Someone sent me a picture in Iraq of a dust storm just recently that was sort of like this. And I have it somewhere. I'm getting so much stuff, I get lost with it. I don't know where it is now. It's somewhere in my computer. But anyway, that's what a dust storm would look like. The winds might be calm before it, southeast winds, and suddenly a cold front come and dry, cold front. And some of the dust drifts during the Dust Bowl era covered houses. So using that as an analog for some of these exotic features, well, first of all, why do we have late Ice Age dust storms? Because the winters are colder winters, and warm in the tropics, you have a stronger north-south temperature difference, and that causes stronger jet stream. and a colder ocean, more sea ice, drier atmosphere, stronger north-south temperature difference, strong jet stream. It all adds up to dry, windy, powerful storms. In fact, we have evidence of this windblown silt much of the mid-latitudes of the Earth. Much of North America is covered with it, some places quite deep, especially around river valleys where it became trapped. You have it in North America, along the Mississippi, for instance. So here's kind of animation of what I think happened. They died. Woolly mammoths peacefully eating grass and buttercups. Buttercups, yeah, because they have them in their mouth and in their stomach. So buttercups is kind of a big thing, so we got some buttercups sitting there. Suddenly the wind picks up. He turns his back, and he acts like a snow fence. The dust kind of piles up all around him, and it's going so hard, it's filling up his lungs. He's suffocating, or he's bearing, and he's in a general standing position. And then as he tries to move his forearms, the torsion breaks his forearms. And there's some analogs for this in Hot Springs, South Dakota, where some of the 52 mammoths they have excavated out of hot springs have broken, shattered forelimbs from being mired in the mud. This time, this would be mired in this stuff. This is like snow. It packs hard, and so it's really hard to move in it. So that's how I'd explain the shattered forelimb. And the forelimb indicates that it was alive when he broke his forelimb. So he gets buried. And more of them cover him up until he's totally buried. He's in the permafrost. I should say he's in the dust. And by the way, some places are 200 feet thick. In some places in Siberia, this dust. The permafrost comes up to meet him. He doesn't have to be jammed in the permafrost. And permafrost faults. That's how I postulate that he broke its pelvis and its ribs, faulting in the permafrost. So you can read all about it in there in a lot more details. This is just a teaser. In Frozen in Time, the Woolly Mammoth, the Ice Age in the Bible. It's a layman's version of what I've written on the Ice Age. And there's also a video, which there are none of them downstairs. This Answers in Genesis puts this out, but I don't have any. Number 4, disharmonious associations. Are they rare? No, they're the rule for the Ice Age. Late Pleistocene communities were characterized by the coexistence of species that today are what's called allopatric, that is, not climatically associated. You had warm climate animals living with cold climate animals, implying cool summers and warm winters, I might add. And they're presumably ecologically incompatible. Disharmonious associations have been documented for late Pleistocene, that is Ice Age floras, that is plants, terrestrial invertebrates, lower invertebrates,